I'm Anil Kumar. We are exploring transformations of polynomials. Here is a practice test question for you. The question is, describe the transformations that were applied to y equals to x to the power of 4 to produce the following graph. Then write the equation of the transformed function. You can pause the video, write down the equation, describe transformations, right? And then check with my solution. Let's begin by describing the transformations. We know how y equals to x to the power of 4 looks like. Let me kind of sketch that part. So it is 0, 0. 1 will give us value of 1 and minus 1 will be 1. That is the value. And for 1 it is 1. So it is like a parabola but more flatter here. So that is why you see a kind of flat thing. Do you see that? So more flatter here and than a parabola. So it is a graph which is like this, and this is y equals to x to the power of 4. Now we have to write transformations applied to this function to get that. That is the question. So clearly, what do you notice? We can begin by stretches, reflections, and then translations, right? So what you notice here is first, it is opening downwards, and therefore we see that there is a reflection on y-axis, x-axis, I'm sorry. So there is a reflection on x-axis since it is reflected upside down, right? So reflection on x-axis. You also note that the right side now is down, not up, right? Now, second part is to consider the stretch. So what I mean to say is that we're looking for a function which is, let us say, transformed function g of x equals to a times f of, in this case it is x to the power of 4. So we'll write x minus p, let me close the bracket, square. We will consider horizontal stretch or compression as 1 for simplicity, plus q. So that is the kind of equation we want to derive at. So we'll kind of describe this transformation in these steps. Okay, so let's get into now the vertical stretch or compression part. So what you normally see is that if you move 1 unit to the right, the graph moves 1 up. In this case, if I move 1 unit to the right, we move how many down? So this point here is, let me write again, this point is 3 minus 2. Is it okay? 3 minus 2. So you basically move 3 units down, right? From 1 to minus 2. So since you move 3 times, 1 up, 3 times, negative direction, so the vertical stretch is 3 times. Reflection on x makes it negative. So we say vertical stretch by factor of 3. Correct? 3 times. Now, as far as the translation is concerned, we see that this point at the origin has moved horizontally 1, 2 units, right? So this is 1 and 1, 2 units towards right. So 2 units right. So translate 2 units right. And what else? 1 unit up, right? So it goes 1 unit up. And then it moves, translate 1 unit up. So that becomes the description for the transformation. Now we need to write the equation of the transformed function. So we'll consider this general equation and then write down the equation for the function. Let the function be g of x. In that case, g of x is equals to, since the right side is down, you see right side is down, so a has to be negative. A is the vertical stretch factor, which is 3 in our case, so it is minus 3, right? So we get minus from reflection, 3 from vertical stretch, and the function we know is to the power of 4. I'm sorry, this is to the power of 4 x 2 units to the right means minus 2 to the power of 4. 1 unit up means plus 1, correct? So that is how you do get the function. So that is the equation from the graph of the transformed function. Now I like you to check whether this equation is correct or not using the given points. So you could use these points to check if your equation is absolutely correct or not, right? But I hope with this simple video you get the concept. So we have few videos on cubic and now this one on quartic function. They should help you to understand how to write equation from the given graph using the knowledge of transformations. I'm Anil Kumar. You can subscribe and share my videos. Thank you and all the best.